we're going to go through the homework quiz, the group meeting quiz for our exam, and we're hoping the rest of our group will join.
That would be good.
So for question 2, in an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared educational level, high school, undergraduate degree, master's degree, doctoral degree of people who manage successful startup companies in the United States and Korea. You want to determine if education level of managers of successful startup companies is independent of country they are from, United States and Korea. Which hypothesis test would be most appropriate for this analysis? Well, this is categorical.
Yeah, so I'm thinking it's test of two proportions. Because we've got the two samples and we're breaking them up into categories as opposed to like the monetary value of their companies or something like that.
So the proportions are categorical?
I think so.
Okay.
Question 3.
Is this in, were these in our last unit or are they in this unit? Or is it kind of both?
I think it's kind of both from when I was scanning over the quiz.
Because I think some of these we studied in our last unit.
Yeah, probably.
I need my notes.
I've noticed them here and there. They just units.
Yeah, they are, because the two sample t-tests and dependent samples were in last. And ANOVA was in last. Okay. Next question. A human resources manager reported data from a recent involuntary reduction in force at her company. You are an attorney and want to determine if age discrimination was a factor, if it is illegal to discriminate against employees because of age. The company reported the number of employees in two groups, 40 years old or younger and over 40 years old. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally. Which hypothesis test would be most appropriate for this analysis? It's categorical.
Yeah.
So it would be, I think it's two proportions. Because it's 40 years or younger and 40 years or older.
Yeah.
Right?
Because we've got the two groups. I think it's test of two proportions as well. Number 4. A survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Oh dear. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. Which hypothesis test would be most appropriate for this analysis? Let's see. Random sample.
Categorical as well.
Well, I don't know if it's so much categorical.
Well, what are we measuring here? Gender?
You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population.
Oh, okay. So heavy versus not
heavy.
So wouldn't this still be categorical? Because you're not measuring any unless the number is the 152, the count.
Yeah. And I think that's what we're going for.
So it would be quantitative?
I think so.
Okay.
So, I mean, I could be totally wrong here. But
Would it be a paired sample t-test?
no, because if it was paired, then the not heavy males would have to be reliant upon the.
The heavy males, that's right. So independent sample?
I think independent sample t-test is what we're looking for.
Okay.
A student project compared the effectiveness of two different combination locks. One of the locks turned clockwise first, and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The time it took them to open each lock was recorded. They want to determine if one of the locks was easier to open. Which hypothesis test would be most appropriate for this analysis? Okay, so we've got 25 students as our sample population. And it's totally quantitative.
Quantitative
So-
because it is the time.
Yep.
Would it be paired sample? Because you want the difference, right?
Let's see. Yeah, they want to determine if one of the locks is easier to open.
I think it's a paired
Yeah, and it's
sample.
the same student, so it would be paired. If it was one lock and then you had a whole bunch of students come and try it, it would be independent. Okay.
Let's hope that that's correct.
Yeah, we'll find out. For the next three questions, identify the one confidence interval that is most appropriate for the given situation. A bank employs two appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence interval would be most appropriate for this study? Value the same types of properties consistently. 6 properties that both appraisers had recently valued. So that is related to the appraisers.
The appraiser. And they're evaluating the same property.
Yeah, so I would say,
And is it quantitative or categorical?
Yeah,
Quantitative, right?
it's quantitative because they're looking
At the value.
at the value.
Do you think it's paired?
That's what I'm trying to think through.
Me too.
Because
They're evaluating the same property, but it doesn't. That property is not dependent upon. The appraiser is separate.
yeah, but we've got more than one sample going on. So I would say paired for now.
Okay.
I think.
Because they want to see the difference, don't they? When I think
Yeah.
about paired, I think it's when they want to see the difference.
Well,
I don't know.
oh, no, you're good. I don't know either. So I'm going to go and take a look on the Googly Poo and see what it has to say.
Where is our I need to do all of my notes. I'm gonna read all of these. I haven't been doing very good reading my book. It's probably why I didn't do so awesome on the last exam. Two means. So that's what I want your help on after our thing, because The professor has this cool little, it's lesson 12 if you're looking for the two means paired data. Our professor has this cool little flow chart that we can fill out and put notes in, and that doesn't count our 1 page of notes. And so I wanted to put this together and then send it out to everybody to use.
Yeah. I have to go take care of something real quick. I'll be right back.
That's fine.
Hello?
Hey.
Oh, hey guys, sorry I'm late.
All right. How are you?
Good. I just went to get a temple recommend and they gave me a number to wait.
Oh,
I've never seen that in my life.
neither have I. I've never heard of that.
I thought he was joking. He's like, take a number. I was like, and they weren't joking.
Do they have a lot of people wanting to go?
Yeah, there's like probably 10 people there waiting.
Oh, wow.
It's crazy.
But he'll give it to you after you have the interview, right? You don't have to
Yeah.
take a number
Yeah.
after that.
Mm-hmm.
Oh, that's good.
It just took forever to wait. Okay.
That's all right. You're here now.
Yeah, I'm
That's
sorry.
helpful. No, it's helpful. Ben had to step out for a minute to get to do something. So,
Okay.
so Evan, if you just want to pull up your quiz, we'll go over the first few questions that we've done.
Okay. Whoa, it's long.
Yeah, because it's before our exam.
Oh, yeah.
We
You
have an
guys
exam
have
tomorrow.
you taken it yet?
No, absolutely not. I haven't even put notes together yet.
Shoot.
Because I really need to study for this one a lot more because I didn't do as well as I wanted to on the last exam.
Yeah. I think I got like a 76 on the last one.
Yeah, that's about what I got. I think I got a little bit lower than that.
The
And
thing is, like, I understand most of it, but there, I feel like in the test, I don't know why, but I'm just not very good at taking tests,
that's how I feel too.
especially the multiple choice, because it's like, well, was it that one?
It gets confusing.
Yeah,
And the way they word it, I think, gets confusing to me.
me too.
Okay, sorry that took a little bit longer than I thought it would.
Okay, so Evan, if you have this open, question 2, we put test of 2 proportions.
Okay,
Question 3, we put test of 2 proportions.
okay,
Question 4, we did independent sample t-test. Question 5, we did pair samples t-test.
okay.
Question 6, we did pair samples t-confidence interval.
Mhm.
Question 7 is the one that we're on. So it's in a Wall Street Journal article on a satisfaction with 2 career paths. The percentage of psychology majors reported they were satisfied with their career path was reported. The same data was also reported for accounting majors. You decide to construct a 95 confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate? And I put confidence interval for 2 proportions. Or
Yeah, I would say
1.
probably.
Is it 1 or 2?
I would think it's 2 proportions.
You have psychology and accounting.
Yeah. Mhm.
If it was like just psychology, then it would be 1 proportion.
Yeah, that's what I thought. Question 8, double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide if you want to know if there's a true assertion of the company who makes them. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount double stuffed Oreos in order to compare it to the filling amount in regular Oreos. Which confidence interval would be most appropriate for this study? This is quantitative
Mhm.
and is it paired?
I would say it's 1 sample.
1 sample T confidence interval?
Yeah.
Mhm.
Because we don't know anything about it, like standard deviation or anything like that.
Okay. So 1 sample. Okay, next question. Which of the following best defines the notion of the significance level of a hypothesis test. I put the probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true.
I think
Or is that wrong? That's
the
Yeah.
p-value. So I think what we should be putting here is the probability of rejecting the null hypothesis, whether it's true or not.
Yeah, that's true. I'm just reading this in my notes here. So it is the probability of rejecting the whole null hypothesis.
Mhm.
And then 9 is the probability of observing the sample statistic more extreme than the one actually obtained.
Yeah. So you were just looking at the wrong one. That's all.
Yeah. No, I got
You're
it.
totally right.
Where does it say? Where is my p-value in here?
Okay. Suppose you create a 95% confidence interval for a mean. You get 10 and 20. You've been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. Exactly what does that mean? It means that 95% of all 95% confidence intervals actually contain the true mean.
That is what I'm going to put.
Because it always seems to be that weird convoluted one.
Weird one. Do we understand why?
I don't.
Second one?
Do what?
The second one?
Yeah.
Yeah. That's exactly what I was thinking, because it seems to be like the one that it's not, so it's probably that one.
Well, I don't quite understand what they're trying to say there, but it's always that weird 95% of all 95% or whatever.
Yeah.
Okay, next you take a simple random sample of 100 adults from the town in the western United States to determine the proportion of adults in the town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is 0.30 or 30%. What is the mean of the distribution of the sample proportions? Is it 0.30?
I believe so.
Because I thought P was the mean.
Mm-hmm.
What is the standard deviation? And Ben, you're gonna have to help. You're gonna have to remind me on this one.
Okay, I'm thinking. Huh. I'm trying to remember. There was something about.
We need the mean and then the number. It's not the P hat.
Let's see. I would think that would be 30. I wonder if that changes anything though. Nope. No, it does not. At least for the confidence interval. So I put it into the one sample z-test for a proportion.
Okay.
And with an x of 30, because it's 30% of the 100,
Okay.
And an N of 100, it's saying that the standard deviation of the confidence interval is 0.05 or 0.046.
Okay, that's what it has. It has this on the practice quiz.
Oh,
So I'm gonna try it. 0.046.
uh-huh.
What is the probability that your random sample of 100 adults will have a sample proportion less than 0.25?
That's easy. Let me just change the sheet.
Let me open this sheet and do it with you here. History bookmarks. No, is it your categorical data analysis?
Yeah.
Or inference procedures?
I'm using the categorical data analysis. But I could be using the wrong one. I don't know.
Well, this is one proportion, two proportions.
Yeah.
Okay, so X, did you do X as 30?
Yep.
100. And you left the confidence interval at 95?
Yeah.
What was your null hypothesis?
For question 13, it didn't matter. I tried changing the null and nothing happened.
What was it?
It was sitting at a default of, I think, like, I don't know. I changed it to 0.7 is the last value I had thrown in there just to test.
For the
Yeah, but what is the probability that your random sample of adults will have a sample proportion less than 0.25?
So don't we have to put this in the normal probability applet?
Yeah.
So what would our z-score be?
That is a good question.
So if we go to So do we just put 0.25 in the normal probability applet and then just shade to the left? What is your probability that your random sample is less than 0.25? That's not correct because none of these are on our sheet.
Nope. Okay.
How do I do this problem? There's one like it.
What is the probability that your random sample of 100 adults will have a sample proportion less than 0.25? So a quarter of the 100 adults would be 25 adults.
Yes.
So maybe if we put our null hypothesis as 25 and then just change the type of test to less than. Let's see what happens. Oh, bad things happen.
Well, it gets our right p-value 0.124, I think. But you gotta change your x, I think. Our number is still 30. Well, I just put, I changed the null hypothesis to 0.25, left the confidence interval at 0.95, and I got a p-value of 0.124, which is on the options on the quiz.
Okay.
So I'm not sure.
Sure, we'll give it a shot.
Change, no. So 0.124. Acupril is meant to control hypertension. In clinical trials of Acupril, 2,142 subjects were divided into two groups. The 1,563 subjects in the experimental group received Acupril. The 579 subjects in the control group received a placebo. Of the 1,563 in the experimental group, 61 experienced dizziness as a side effect. Of the 579 subjects in the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of the people who experience dizziness while taking Acupril. Let P2 be the true proportion of people who experience dizziness but do not take Acupril. Create a confidence interval P1 minus P2, input margin of error, lower and upper bounds rounded to the 3 decimals.
Okay. So I think this one, we might need the quantitative.
Inference.
Yeah.
Because this is our paired sample. Right? Because we're doing the difference.
I think so.
Is it a pair? Yeah, it's paired. So our variable 1 is going to be $61. And variable 2 is 15.
Yeah, I think so.
Am I doing this right?
I think so. I'm trying to reason through and 579 subjects in the control group.
2142.
I feel like there was a formula for this. Like a really easy one.
P1, P2. Why don't I know more about this? What is our mean in here?
Okay. Haha. Why don't we just do it this way? What is the margin of error? Let me see if I can find the margin of error in here real quick. Oh, good gravy. That's not an easy equation at all.
Where are you looking?
Oh, lesson 18.
Lesson 18.
Yeah. Inference for two proportions.
Is this our two proportions or
Thinking so. But let me make a mental note real quick. Okay. Let me go back and look at inference for two means. Let me see if that one makes more sense.
null hypothesis? We see P1 equals P2 after subtracting P1 equals 0. In the null hypothesis, we see.
I'm not seeing anything for that one though.
Okay, I wish I was more help right now.
You're good. I'm not being much help either. You know what? This is stupid. Why don't I just go back and look at, let's see. We did this in a quiz like last week-ish, maybe?
Did we?
I think so. So I'm going to go take a look at the quizzes for the last couple of weeks. Okay. So the question is, how did we do this? It is for lesson 18. Because right here, create a confidence interval for P1 minus P2.
Okay.
Input your answers for the point estimate margin of error.
So it's not hard then. Here, let's go back. So it's not the inference procedures. It is the categorical data analysis, and it's two proportions. So our x1 would be 61.
Okay.
Our n1 would be but is P2, I'm going to try this anyway. 1563 is our N1. X2 is 16. N2 is 579. confidence interval is 95, and then I'm going to put does not equal.
Okay.
So what was our question?
What is the margin of error?
So the margin of error, I have confidence interval of,
This seems awfully familiar.
so I have my confidence interval, I have negative 0.05 and 0.028. But I don't think this is correct because it's not on one of the answers on the homework. So I don't. 6.
Um, Let me take a look at the homework.
That doesn't seem. I think this is the right spreadsheet.
Um,
We can go off of what I had and try it, but it might be wrong. And I don't want to keep you all night.
no, you're totally fine. Don't worry about it. Let's give it a shot.
So the confidence interval that I had was negative 0.05 for the lower bound.
Wait, 0.05 or
0.005.
okay. Yeah. And then the upper bound is 0.028.
Yes. That's
So I went ahead and subtracted 0.028 minus a negative 0.005 and then divided all of that by 2. And that should give us the margin of error,
yeah.
which is 0.0165, so 0.017.
Okay. Okay, so 0.017, lower bound negative 0.005, upper bound 0.028. Perform a hypothesis test to see if the proportion of the experimental group subjects who experiences dizziness is different than the proportion of the control group subjects who do. Use the level of significance of A equals 0.05 or the appropriate null and alternative hypotheses.
Okay, it's different, so it's just P1. The null is P1 equals P2. And then
P1 does not equal P2.
yep. So the very first one. The value of your test statistic is 1.258 is the z-score. P-value of your test is 0.208.
Okay, I'm pretty sure these are going to be wrong, just FYI.
Yeah, that's fine. We'll find out.
0.028.
For 20, it's 0.208. Is there sufficient evidence to conclude that the true proportion of people who experience dizziness while taking Acupril is different than the true proportion of people who are experiencing dizziness while not taking Acupril? We failed to reject the null hypothesis.
Yeah, which I know is wrong. That has got to be wrong.
Yeah, that's okay.
Because isn't our null P1 equals P2 and alternative does not equal, meaning there's a difference?
Yes. But I think that's my best guess for right now.
Okay.
So why don't we go ahead and
Yeah.
run through the rest of them,
Yeah.
and I'll just
Back.
submit first, and we'll see what happens.
Okay.
What'd you put for 21 then?
No. No.
No.
I failed to reject the HO.
Yeah, we have 3 submits, so
Yeah.
Use the following information. Use the following information. A survey conducted of 1279 randomly selected adults aged under age 18 and older. They were asked, are you a morning person or a night person? The hypothesis for the study are being a morning or evening person is independent of age. Being a morning or evening person is not independent of age. The results survey are given here. So this one is our
Chi-square,
chi-square. Yay!
which I like these. They're easy.
I do too. Like, I recognize this.
Okay, the test statistic is 6.579. The p-value is 0.087.
Typing these in. I'm gonna have to do this tomorrow.
Should you reject the null hypothesis or not? Explain. Yeah, we're going to fail to reject it.
Okay, let's see here.
Because the p-value is greater than 0.05.
6 point test this. Okay, I'm behind. Sorry.
No, you're good.
Okay, so 22 6.65
579.
6. I put 6.58. 579.
I'd do 79.
Yeah, I'm looking at the homework too, and it's calculate the p-value, which was
0.087.
7. Should you reject the null or not?
And that's a no, because the p-value is greater than 0.05.
Okay. What do you conclude based on your results? We have insufficient evidence to say
That being a morning person or evening person is independent of age.
okay.
Or actually, hold on, let me double check.
Being a morning person is independent of age. Being a morning person is not independent of age.
That's a good question. Yeah. Null
Oh.
hypothesis is independent. So
isn't it we
it
have
would be is not independent of age.
insufficient evidence to say that being a morning person or evening person is not independent of age?
Yep. That's the one.
Because if we reject it, then we say we have sufficient evidence to say that being a morning person or evening person is not independent of age.
Yeah.
Okay, so it's the last one. I'm gonna
Mhm.
confuse everybody. Okay, a recent book noted that only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers that had graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of the investment managers. based on the sample, create a 95% confidence interval of P, input the lower and upper bounds. Okay, where is it? Is this one proportion?
I think so. So 50 of them outperformed out of 200.
Okay.
Okay, so confidence interval doesn't change depending on the null hypothesis.
Okay, I got 0.190 for the lower bound.
Mhm.
And 0.310 for upper bound.
Yep. And then suppose you were in charge of designing the study, what sample size would be needed to construct a margin of error of 2% with 95% confidence? That's a good question.
So don't you just change your null hypothesis to 0.02? Would be this.
Well, we're looking for the sample size,
Yeah, that's true. So we
so we're going to have to find the corresponding n.
the n. That's right. Okay. So there's a formula for this,
Yep, I'm trying to find it right now.
and we're doing one proportion, so I think it'll be in that section.
Yep. Should
Okay,
be less.
so n equals the z star over m squared times p times 1 minus p star. If no prior estimate is available, the formula is z star over 2 margin of error squared is used. What was our p? P hat? We're going to try it.
Yeah, p hat's constant. So
Okay. I'm talking to myself.
no, you're good. I'm just thinking through.
Oh. Okay, that did not work.
Okay. You can reduce the margin of error. It's the formula for n, we get z star over m squared So let me copy this exactly real quick. U star over m. All of that is the second.
This is not one of our answers on here.
Times
Ben, what did you get for these?
I got some crazy number I'm recalculating because I'm pretty sure I did something wrong there. So I will have another answer in just a minute that will hopefully make more sense. Okay, so P star is equal to 0.2.
Is that our P star?
So the M represents margin of error, right?
Yes.
Okay. So let's go 0.310 minus 0.190. So that would be 0.06 is going to be M. And then the Z star is the one I'm not sure about.
The Z star, I got 1.768,
Okay.
but I'm not sure that that's correct. How about I try this?
Okay. So I got. Oh, okay. Hold on. One 1536.64.
1536?
0.64.
Okay, that sounds correct. Evan, tell us how you did that one.
So I took the formula n equals z, whatever we're calling that, over e squared times p hat,
Okay.
and then 1 minus p hat in parentheses. So that would be, if you want to like write down, I don't know if this is right, but this is just what I did. I
Okay.
took, I got 1.96 for the z thing, z star, and I just plugged in to the table to
Uh-huh.
find at 95% confidence, and I got 1.96.
Did
So,
you do 50 over 200?
sorry, what?
You got 1.96. Is that your p value?
So my 1.96 is my z star, or I think that's what, I don't know what you guys are calling it. The z.
Yeah. Yeah.
Yeah, divided by e, I guess in this case, which is the piece in this case, the p of 0.2 or 0.02.
Mm-hmm.
Then I multiplied that. I don't know if this is right, but I multiplied that or by the 0.20, and then 1 minus 0.20, and then you have to square according to this formula the z over e. I don't know if this is making any sense. It's kind of hard to explain because I hardly understand it.
Okay.
It took a while for me to
No,
get.
you're good. I think I'm following. Are you looking at where are you getting this formula from?
This is in chapter.
I wrote this
Is it in
formula.
lesson 17?
Yeah, this is chapter 17. Yeah.
I wrote it down on a piece of paper that I found for this chapter, or for one of the chapters.
Gotcha. Oh my gosh.
It's in the end of chapter 17.
Yeah. I
But
think I
but the margin of error isn't 0.02.
No, the margin of error is
0.06.
0.06.
So I don't
So
know. But the options are A, B, C, D, and E. B is n equals 1537.
Where do you see the options?
I printed out lesson 20.
Okay.
And lesson 20, it has multiple choice like answers.
Oh,
to
okay.
them.
And what are they answers?
N equals 2401, N equals 1537, N equals 16, N equals 1801.
Oh,
Or
it's got to
N
be
is-
1537.
Yeah.
sure.
Off a little bit, but
But it's not helpful if I don't know how to calculate this correctly.
right.
Yeah.
I would write this. Do you have this formula like handy? I would write it down.
I did, but I put this in and I got the wrong number. I got a crazy number that wasn't
Hmm.
correct.
Are you entering it in the calculator correctly?
I'm just entering, yeah, because I put in X is 50, N is 200, your confidence level is 0.95, your null hypothesis is 0.20,
Mhm.
and then I have my type of test is greater than.
Yeah, that's what I had.
Ben, you know what you have too?
Yeah.
And your Z score was 1.768.
Yes.
Why that's like that?
Difference between these.
But yeah, I want to keep going because we're going to be here all night, and
Yeah.
I might have to wake up early and do this quiz again and just read through all of my chapters and really study. And print out all of my quizzes.
There's just one part to this that I don't understand. But
Okay.
we can move on though.
29. Which of the following pairs of hypotheses is the most appropriate for addressing this question?
Let's see.
Better than us. Is 0.2. So would it be HO equals 0.2, HA is greater than 0.2,
I think so.
performs better?
Yeah.
Sure. Sounds right.
What requirements must be met to ensure that the p-hat's normally distributed?
And P is greater than equal to 10.
Yep. And n times 1 minus p is greater than or equal to 10.
The value of your test statistic.
1.768. P-value is 0.039. Is there sufficient evidence to conclude that graduates from the top 10 business programs perform better than other investment managers? Yes. We
If
rejected the null hypothesis.
If the P is low, we reject the null. So yes, I rejected the null.
First one. Oh.
Use the following resolution. Okay. Computer software is commonly used to translate text from one language to another. Part of his PhD thesis, a phrase-based translation program.
Here, I need to step away again. I'll be right back.
Okay. I'm just going to download this spreadsheet.
I'm typing them in.
Okay, what are we looking at here?
The lower bound and upper bound. 95% confidence.
Okay, so which one am I going to use for this?
I have no idea. What Excel sheet are you using?
Well, I downloaded the data file.
Mm-hmm.
He wants to use the data to see his mean blue scores differs from the mean blue score of another leading translation software, which has a population mean score of 0.95. This has got to be in our quantitative inference procedures.
The older one?
I think so.
Shoot, I'm gonna run. I've got two computers and I just am starting to use my computer that doesn't have Excel on it.
Oh,
I downloaded the new version of it, so I don't have any of my older files.
I sent you the bookmark. Do you want me to send it to you again?
Oh yeah, that'd be sweet. It's been so hard because all my stuff's on my old computer.
I know you got, yeah, and you probably haven't had a chance to transfer it over.
Mm-mm.
Okay, let me send you the bookmark. I'm just gonna put it in the chat.
Okay. Man, this is
There you
crazy.
go.
This week's crazy with the test and this quiz.
I know, and I'm really not very good at this statistics stuff, so I feel useless.
I feel ya. Oh, there it is.
Okay, what is my mean? Zero 0.295. Where is this? 0.295 standard deviation. Okay, this isn't working because I don't have the standard deviation, so I don't think I'm using the right one.
Yeah, I don't know what I'm doing. This one's in the homework, I think.
I think all of these were homework, and I'm gonna go print all of our things off. Because this should be is this a one sample t-test?
Yeah, it's a one sample t-test.
But
And
we
then
don't have the standard deviation, so sigma's unknown.
I think
Do I have to put that in at all? What's my n? 300.
standard deviation 0.287. Is the standard deviation the x bar? I always get the
X bar. What's your X bar?
the hash above it.
Where did you see that?
It's in the homework.
No, standard deviation is the sigma. X bar is your sample mean.
That's right. Shoot. I am not getting this one.
Trying to think. Let's calculate for each. Okay, I know I'm doing this wrong. But it's got to be a one sample t-test
Yeah.
because it's not our 1 proportion, 2 proportion, and it's not a chi-square because we have all of this data to paste into here. And I don't think it's a z-test.
No.
Because I thought z-tests were sigma known. Histogram. Nope, this isn't it. Okay, so this is what I got without the standard deviation. I don't know if we need to enter it in or not. The null hypothesis.
Okay, sorry.
Is
How
our
far did you guys get?
number- I'm still trying to figure this one out, Ben.
Oh, okay.
So I think for this one, we use the one sample t-test, correct? Because you download the spreadsheet and you have the blue score. And then you have a whole bunch of data in there.
mm-hmm. Oh my gosh, we've done this one before.
We have. So that's 100. Okay. So I put it into the one sample t-test for means. I put the mean in as 0.295 because that's our population mean that they gave us. We don't, the sigma is unknown, which is our standard deviation. So I left that blank and then I put n as 100.
Okay.
So would you do the same thing?
I think so, yeah.
So and then I left the confidence interval at 95.
Mm-hmm.
The null hypothesis is 10. I don't know what the null hypothesis is supposed to be. Oh, right here it says 0.29. Hello.
0.295.
Okay, and then I did not equal to because that's our alternative type of test. So I got our p-value as 1. So our p-value is greater than our level of significance, so we fail to reject the null, which means we have insufficient evidence to say that the true mean is different than 0.295.
Mm-hmm.
Correct?
The third
Yes.
one.
Okay. Just to grab the numbers real quick. What was 34?
1 second. So my lower bound is 0.290. My upper bound is 0.300.
Okay. And then degrees of freedom.
It'd be n minus 1, correct?
I
To
think
be
so.
99. It's not in this spreadsheet. Oh, yeah, it's 99.
And put the... Okay, and what did you get for the t-score?
The t-score is... Let me open it 1 second. 0.000.
Okay, and then the p-value?
1.
It's
1. Okay, that's what I thought. Okay. The home stretch, last set.
So we have insufficient evidence to say that the true mean is different than 0.295.
Yes.
Okay, I'm going to write down which test I used for this one. I did the one.
One sample t-test, right?
Yeah, that's... Okay. Next, home stretch, yes. 34, okay. A study was done to test the notion that people were taller when they first wake up in the morning than when they go to bed in the evening. To test this theory, the heights of children in a boarding school were measured. Okay, let's download this spreadsheet.
I feel like we did this one too.
Yep, we
We've
did.
done all of these. But now they're all together. So is this a paired sample?
Sounds right.
Yes.
I'm pretty sure that's correct.
I wish I just remembered it all.
I know, right?
Plug them right in there.
And E.
Okay. So lower bound 8.728. Upper bound is 10.455. Statistic should be 22.446. P value.
What was the
Should.
number?
Oh, good gravy.
What was your N?
N is 41.
Okay, and do we have to put in the mean or the standard deviation?
I don't think so.
Okay, and then our null hypothesis is
The null hypothesis is that they're equal. And then
equal to
I think it's actually less than,
or okay.
because the study is asking if they're taller in the morning.
Taller in the morning.
Yeah. So the null hypothesis would be that the height in the evening, so variable 2, is less than variable 1.
P1 is no, wouldn't it be greater than
Yeah, P1 is greater than
P2?
P2.
So wouldn't your type of test be greater than?
Yes, I had it backwards.
Okay.
Okay. So all that really changed was the p-value, which it didn't change it enough. Because we're still at -24 exponent. So the p-value is going to be 0.000.
Okay, but your test statistic, I have 22.446.
Yep.
Okay. We're going to try it.
And then degrees of freedom is 40. Let's see. Based on your results of this test, is there enough evidence to suggest that children are taller in the morning than in the evening? Yes, because we rejected the null.
Okay, let me see here.
So
I need this open again. So my lower bound is 8.728.
yes. Okay. Let's see how we did.
What do you put for the upper bound?
10.455.
I guess that's not terrible.
How do we do?
74%.
Yeah, it's horrible. I think I'm just going to wake up tomorrow and do it.
I've done worse.
Okay, which ones did we miss? Is the last one correct?
Yes.
Okay, I'm going to write all these down of what I did. 22.
Which ones did we get wrong?
Well, let me start from the top.
Where do you want to start?
Let's start with question 2 because we got that wrong.
Oh gosh. Okay.
So 2, 4,
Ugh.
9, 14,
Ugh.
19, 20, 34, 35, 37, 38, 39.
Oh,
And that's it.
okay. Not terrible.
Yeah. And I mean, a few of those, it was if you got the first one wrong, then the others were going to be wrong.
Yep.
So,
Yes. Okay. So let's go clear back to 2.
Okay.
Question 2. In an article of a Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. High school, undergraduate degree, master's. You want to determine if an educational level of managers of successful startup companies is independent of country they are from, United States and Korea. Which hypothesis test would be most appropriate? So that we put test of 2 proportions.
yep.
So would you
I'm
say it's an
thinking
independent sample
independent
t-test?
sample t-test.
I didn't think this one was quantitative though. We're gonna try it.
It's not. Dang it. Okay. But it's more than one proportion, right?
Because it's 2 countries that you're measuring.
Yeah.
Because you're doing education level.
Yeah. I don't know. Maybe it is test of one proportion.
Is it 1 proportion?
I would try one proportion
Okay.
because you're right. It's qualitative, not quantitative.
It's categorical.
Yeah.
Okay.
Okay. And then question 4.
What did you decide on for 2?
1 proportion.
Okay.
A student project compared the effectiveness of 2 different combination locks of the locks turned clockwise. They asked 25 students to participate in the study. Each student was given a combination to each lock and asked to open the locks. The time they took to open the lock was recorded.
Oh, no, you're on 5. We got 5 right.
Oh, sorry.
No, you're totally fine.
My numbers aren't the same.
So
4.
4 is a survey was conducted by a group of state lotteries. A random sample of 2406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different from the proportion of males in the population, which is 48.5%. We put an independent sample t-test.
Yeah, but I think this one's categorical.
Yeah.
And I think it may be. Is it 2 or 1?
That's a good question.
Isn't this 1? Because you're just doing the lottery players?
I don't know. We can try it. It's either 1 or 2.
I don't know. We have Evan.
Yeah.
We'll have one more submission.
Yeah, Evan can save us.
Sorry, I'm still reading number 2.
Are you guys positive it's the one proportion?
Well, we did test of two proportions.
Would it not? I was thinking ANOVA, and I'm reading up, and I guess it kind of makes sense.
Does ANOVA allow for
Categorical.
categories though?
Oh,
Because that's the hang up there is it's not numbers, it's
Categorical, yeah. I'm gonna try one proportion.
okay. I'm gonna keep ANOVA, and then I'll submit, and then we can see. I guess whoever submits first. Unless you guys want to don't want to go through it again.
I don't care.
Okay, what's our next question that we missed?
The next one is question 9.
Okay, these don't match on my thing, so this doesn't help. I gotta scroll.
Which one of the following best defines the notion of the significance level of a hypothesis test?
Really?
Yep.
It says right here, the level of significance is the standard for determining whether or not the null hypothesis should be rejected.
And that's what I thought.
A type 1 error. The probability of a type 1 error.
Okay.
Okay.
What do you guys put for 5?
5 is a paired samples t-test.
The
Okay.
probability of rejecting the null, whether it's true or not.
Yeah, which if that's wrong, that's weird because that's the definition that I had in our last notes. But
Yeah.
I'm going to say it's the probability of a type 1 error. Okay, what's the next one that we missed?
Next one is 14. And that is, what is the probability that your random sample of 100 adults will have a sample proportion less than 0.25?
Okay. What was the spreadsheet that we used on this one?
I don't remember.
This one was this the one proportion?
Yeah, I think so.
Okay. I think we did do this one. And X was 30. N was 100. Confidence level is 0.95. Null hypothesis is 0.30. Try less than 0.250. So the probability that wouldn't be your p-value, would it? Let's try this. Ben is 0.876.
Okay.
Okay, I put X is 30, N equals 100, and null equals 0.25 less than. Okay, let me change. Sorry, I'm slow.
No, you're totally fine.
I'm writing all these down because I'm gonna have to study them tomorrow. Hey, what was our next one that we missed?
The next one is question 19. And that's the value of your test statistic is.
Question 19.
Mm-hmm.
Are you morning or night person? And,
For this one, we did.
this one was the paired samples t-test.
Yep.
$19 or test statistic.
Yeah.
Oh, this one wasn't our. This one was the chi, wasn't it?
No, it shouldn't be.
No, this one. Yeah.
Acupril. It was Acupril is meant to control hypertension in clinical trials of Acupril. 2,142 subjects were divided into groups. The 1,563 subjects in the experimental group received Acupril. The 579 subjects in the control group received a placebo. Of the 1,563 in the experimental group, 61 experienced dizziness as a side effect. Of the 579 subjects in the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of the people who experience dizziness, and let P2 be the true proportion of the people who experience dizziness but do not take Acupril.
Okay. Are we still in the test statistic 19, or do we go to a different one?
Yeah, that's the test statistic for 19 is the one that we're looking at. So I would think it's the two proportions one. And that should be, let's see. P1 are taking Acupril. And that should be 61, 1563. And then 15 experienced dizziness out of 579 for P2. Value of your test statistic. Oh my gosh, did I type that in wrong? I think I did.
Is it 6.58?
I'm thinking it should be, it's the z-score, and I'm thinking it's 1.458.
Where are you? Which spreadsheet are you looking at? Because
The sample z-test for two proportions.
okay, because I think because we missed question 19.
Yeah,
So this was the two proportions. Okay, these ones.
yeah. And I think I accidentally typed in 16 instead of 15 in the X2. And that changed it from 1.258, which is what I had for the z-score, to 1.458.
Okay, so you changed it to what you changed which one? P1 does not equal P2?
Yeah, I've got P1 does not equal P2.
Okay.
And I had accidentally typed in 16 into the X2 slot instead of 15, which it should be.
Is it 15? That's what I did wrong. 1.458.
Yeah. And then the p-value should now be 0.145 instead of 0.208, which is what I had.
Where is my AccuPro on here? Okay, it doesn't matter. I'll just print this out later. So the p-value is
1.45.
0.145.
0.145. Yep. Okay, and then our next one. So this one would be still no, I failed to reject the null hypothesis.
Yeah.
Okay, what's our next one that we miss?
The
34,
next one we missed is 34.
35,
No.
7, 38.
Yep.
Shoot.
34, 35, 37, 38, 39.
Thir-
So something went horribly wrong with this blue scores sheet.
34, 35, 37, and 39.
37, 38, and 39.
Pardon?
Okay, so let's go back to this one. Which test are we going to be using?
That's a good question.
Would it be the
Um,
sample t-test?
I think so. I'm going to copy all of this. Let's go find quantitative. One sample t-test.
Maybe we don't have a mean. Okay, should I try this without a mean and see what happens?
Maybe.
Okay, so the t-test, I got the lower bound first. I'm gonna write this n equals 100. No.
Let's see. And the null hypothesis was 0.295.
Yep,
And we're looking for not equal to, right?
yep.
Okay.
So for my lower bound, I have 0.282. Upper is 0.293.
Yes.
My p equals negative 2.803. My degrees of freedom equals 99. And then my p value is 0.006.
Okay.
What was
We're
the test statistic? Negative 2 point.
2803.
Then
We're
30.
found 0.293. I wish we had 2 chances on our exam.
I know, right?
The degrees of freedom was correct.
Yes.
The statistic is 0.00. No. No, that's wrong. Negative 2.803.
Correct.
P-value.
And then question 39, since our p-scores changed a lot, should be we have sufficient evidence to say that the true mean is different.
Okay, what's our
That's it.
and then this was yes. Because we rejected the null.
Yeah.
Okay. Is that our last one that we missed?
Yep.
Okay, let me submit mine. Let's hope. Okay, we missed question 2 again, so it is not a 1 proportion.
Gosh dang it.
Okay.
14 is incorrect. 19. Oh, I put a comma instead of a period. Shoot. So that one was my bad.
So it very well could be right.
So 19 is right. I just put a comma. So we only missed 2. Question 2 and question 14 and possibly 19. Typo. So let's go back to question 2. What do we think?
Okay, so it's not test of 2 proportions, not test of 1 proportion.
Yeah, so it has to be categorical, which makes no sense.
Oh,
Number 2.
you know what? I bet you it's a chi-square.
Is it a chi-square?
Yeah, it's gonna be a chi-square.
On number 2.
Yeah, now that I'm thinking about it,
Yeah,
'cause
it is a
square
chi-square.
represents a whole bunch of different
Yes.
categories. We have more than 2 proportions. We've got a bunch. We've
Yeah.
got 4.
We have
So it's a chi-square.
high school, undergraduate, master's, and doctorate.
Yep. I'm good at this game.
What did you guys put for number 3, 4, and 5? I think I'm 8 and 6. I think I'm off on those ones.
Question 3 was a test of 2 proportions.
Okay.
4 was, what did we decide that one was?
Hold on, let me scroll up.
Test of 2 again.
Test of 1.
Test of 1.
Because you're just doing lottery players.
Okay.
So question 5 was paired
Paired
samples t-test.
t-test.
Okay. 6. Oh,
6 was the paired samples t-confidence interval.
Okay. All right. Do you guys want me to submit?
Yeah, sure.
Well, you're gonna miss the one that you're gonna miss still is 14.
Okay. Let me see.
The probability that your random sample of 100 adults will have a proportion less than 0.25.
I got 0.876, but that was wrong.
That's wrong. So your other option is 0.138 or 0.862.
We go 862.
Sure.
All right.
How you get that? I have no idea.
And number 2, we're gonna go with chi
Chi
square.
square.
Uh-huh.
All right. Submitting. Looks like a 39 out of 43.
Gosh dang it.
It's more than I missed.
I think I may have marked a few down wrong.
Maybe so.
Oops.
Was 14 correct?
14 was not correct.
Okay. So, Ben, going off of what's on my sheet here, I'm going to say it's 0.138.
Fair enough.
But I don't know how you get that.
Beats me.
How did I get? That was 14. How did I get numbers? I'm pretty sure I wrote them down wrong. Number 15?
15 should be 0.017.
Oh, oops. And 16 and 17 I got wrong too.
16 should be negative 0.005.
Oh, I put them in the wrong order.
17 is 0.028.
Wow, now I'm gonna have to go through this again.
Yeah, I'm not bothering.
Other than that, though, it's good. It's solid.
Do you want to go to bed? It's like really tired.
I'm probably gonna have to take the test tonight.
I am not going to take this test until tomorrow afternoon. Ben, are you taking this tomorrow morning
I don't know. I haven't decided yet.
or tomorrow afternoon?
One of the two.
If you want to get together in the morning, we can go through the flow chart thing.
Yeah,
you're
I
busy.
might have a little bit of time. It
But
depends
if
on-
not, I'll just do it myself.
And what'd you guys put for number 10?
10 should be the probability of observing a simple statistic more extreme than the one actually obtained, assuming the null hypothesis is true.
Oh, okay.
So I'll probably be able to like chat and work on it, but I don't know if I can do video because I'll be at work.
Don't worry about it. If you don't have time, it's not a big deal.
Oh, it's okay. I'm waiting on other people for stuff that I'm doing at work right now, so I have spare time.
Luckily, I took the day off.
That was smart.
I really just don't want to fail.
Yeah, I can understand.
Yeah.
I might just call in sick. I don't know. I haven't decided yet. I haven't had a day off in months anyways, so
So you need a day off. Okay, where's my meeting quiz? I'm gonna try this again.
okay.
Me too.
My first.
Do you want me to just read them to you?
Oh, I'm good. Number 1 is true.
Okay.
2,
Well, I'm gonna call it a night. I'll let you know what is going on tomorrow, Marie.
okay, sounds good.
So
That's fine. Just text me. If not, no big deal. I'm gonna have to wake up early and look at all of this and hope that I remember.
okay, sounds good.
Okay, have a good night. See ya.
You
You
guys.
too.
Are you jumping off, Evan?
Yeah. Did you